right, we are back from break. And George, I'll turn it over to you.
Thanks, Laura. Well, our last session, as you watched the video during the break, I couldn't give it any better of an introduction to what Dave Jones did. But our next session is data quality and confidence, and that is so important in dealing with these types of incidents, whether it's weather related or man-made type of hazards. So this session is going to be moderated by Dave Jones, who's a CEO for Storm Center Communications. And he's been a real subject matter expert with all of us in the All Hazards Consortium. So it's my pleasure to turn over to Dave, and he'll introduce the number of panelists that we have for this session. Dave?
Oh, well, thank you, George. I really appreciate that, and welcome everybody to this session. It's been an incredible week so far. We are talking about data quality and confidence, and I think I'll be sharing my screen, I believe. And let me go do that. So I'll pull up this particular presentation, put it into play mode, and it's called Enhancing Data Confidence. Is that showing the right screen, or is it?
Yeah, it is, but you're not in slideshow mode.
Okay, it just went over to my other. Let me just stop this just for a sec. Went over to my other monitor. Okay, how's that? Is that better?
Perfect. Yeah.
Okay, great. So we're going to be talking about enhancing data confidence. And I did mention that in the introductory video that I talked about with ORL levels. And so we have with us some great panelists today, and ones that are very accomplished and been working on this for a long time. And that is Greg McShane with DHS CISA. Greg's going to talk a little bit about why do they care about data quality in CISA. I'm certainly glad that they do. And he'll give us a little bit of an overview as to how that is important to their operation. And then we're going to talk to you about how this came together. So we're going to have Carrie Hicks, who is a senior GIS analyst with Bent Ear Solutions. And Carrie was formerly with Duke Energy, and so she has a lot of experience dealing with data, bringing it in quickly, determining what do you trust, what do you use, what came from left field that you may not want to trust at all. And then we're going to talk to Karen Moe, who then used to be with NASA in their Earth Science Technology Office. And that's kind of the model that we pulled from to create the ORL levels. And then after that, I'll go into a couple of slides and show how we're operationally using ORL levels within the GeoCollaborate dashboard. That's the public-facing part of the sensitive information sharing environment. So we'd like to make this interactive. If you have questions, please put them in the chat. We'll be monitoring that, and we can answer those questions as they come in. So I'd like to move on with our first presenter, and that is Greg McShane, who is with DHS. Greg, take it away.
All right, thanks, Dave. Appreciate that. And thanks everybody on the phone or online here hanging on this late in the day. I think you're going to get a lot of good information, and hopefully we can get some good feedback from you on some of the things we are working. Just a little bit about myself here. I got about 30 plus years in the area of federal government, consulting, electric utility, and engineering. By trade, I'm a civil engineer. I got an MBA in finance and some of my background. I'm also a certified business continuity professional. But the last 16 years has been really working for CISA in the Integrated Operations Division, the technology branch, focusing on really IT strategies to capture and implement system requirements, things that need to cradle to grave to support and really complement CISA and its regional operations, both in the areas of physical and cyber operations as well. Some of the highlights, we have weekly Friday meetings that are just so energizing. We're doing a lot of problem solving, and we're actually implementing capability on our All Hazards Consortium SICE called Sensitive Information Sharing Environment, and our GIS. And it's becoming a lot more than just GIS. We're getting into a lot of the data elements, et cetera. But it's the All Hazards Consortium is just really, been an extended arm for a lot of things we're trying to do in solving those operational problems. It's really, identifying those use cases, whether it's supply chain issues, lodging, fuel availability, restorations, pre-staging, damage assessments, and the approach we have for use cases is really, defining that problem set to solve and really identifying those right people at the, bringing those to the table, bring those folks to the table, identifying those data sets or authoritative or trusted data sets, identifying those right processes and right technology to solve that problem. These are just really key ingredients to this, the success and recipe to success on interactive capability tools that we're always striving to build. It's that public-private sector relationships we're always building on. And the AHG membership is just so key in helping us identify and solve some of those problems. On our watch operations, we've always, our leadership in CISA Central or regional operations, they're always asking us, what are you doing? And what's going on and what are you doing about it? So, they're really proactive when it comes to, the reporting and information and coordination. But, another refreshing part of this in my job is, on the data side. And this is something I've been working on, back in, when we were called Infrastructure Protection, on a data work group that we were all sitting there at the table, where do we support our CISA gateway and identifying data sets and quality, those types of things. And we've been at it for a long time, but really refreshing is that now we have a chief data office within our chief technology office, and we have people dedicated to this full time and implementing those capabilities across CISA and its divisions, identifying those data experts or developing a data stewards program. But it's really refreshing. Again, when it comes to data quality, we're really defining some of those requirements, from just the definition. It's the state of the excellence that exists when data are relevant to the intended uses, are sufficient detail and quantity, with a high degree of accuracy and completeness and consistency with other resources, and presented in appropriate ways. It's about understanding those data elements, from the accuracy, completeness, timeliness, relevance, reliability, consistency across the data resources, appropriate presentation, accessibility. And I think you're going to hear from Carrie and Karen and a little bit more from Dave on some of those and how it rolls right into the operational readiness level, tool and capability. We've got some really aggressive goals within CISA, defendable products and known confidence for data decision making, identifying those external facing products, such as the status of power delivery recovery during a hurricane event, things of that nature. It's great to see that, the data quality efforts are done through a data stewards program. We're further maturing our data governance. We're cataloging a lot of our data inventories, and a lot of the metadata within that. It's identifying those data dictionaries that support that data within the data, and efforts like that. So, one of the things that's really on the next kind of phase or next steps is really identifying some of those data quality plans that support that data, and how is that done? How do you fix some of how do you make it better? Those are questions that we're trying to solve in some of the data quality management plans. You have this huge data set, and are you doing a planned sample? Are you doing a random sample to make sure that the data is correct? We have a stakeholder relationship management tool that we're building, and that information has to be right, and we've got to build on that and build those libraries. And the accuracy of that information is very key with the data confidence and understanding, making that recommendation to leadership with that confidence level. So these are things that we're working. A lot of the data standards, the data glossaries, defining those terms, understanding those terms, understanding the data that's behind it. So, we're working the framework parts of this, and then and ensuring our data catalogs are current. So these are really great things that we're working on, and just wanted to let you know that we are working hand in hand with the All Hazards Consortium to define some of these things and leverage some of the work that they're doing as well. So back over to you, Dave, and look forward to more discussion on it.
That sounds great, Greg. That was a great overview and why data is so important, data accuracy, data confidence in your organization. And as we work to share more data across platforms and from one sector to another and from the private sector to the federal sector, all this really does matter. And so with that, I'd like to introduce Carrie Hicks. Carrie is going to talk about the SICE data efforts, and that's this slide here. Carrie, I'd like to turn it over to you. And Carrie's such a great storyteller. Just take the floor, Carrie, and wow us with your knowledge.
Oh, wow. Really setting me up there, Dave. Thank you. And also great job, Greg, giving us an awesome overview of the SICE and as well as some of our data efforts within the All Hazards Consortium. So as Dave mentioned, my name is Carrie Hicks. I am a senior GIS consultant with Bent Ear Solutions. I did work at Duke Energy for about 7.5 years. So I've gotten a good amount of firsthand experience dealing with different emergency situations, whether that's Hurricane Irma or another planned outage, where the quality and the reliability of data was truly essential. And it was actually in those experiences that, as I came into the All Hazards Consortium, the importance of standardizing a process around data quality and data reliability became so apparent. To give a little bit of background before I jump into this slide, something that we really realized was that as GIS professionals or data professionals interact with operational folks or people that may not be GIS or data experts, a lot of the time there are translation challenges that occur in those interactions. So I might, for example, add a data set to a dashboard and then send the link onto a decision maker or someone in operations. And I might say to that person, hey, this data set, I got it online. I'm not sure how reliable it is, but it seems pretty reliable. Good luck and Godspeed and use that data to make decisions, right? Which is how many of us operate in that space. Well, that person might then send that dashboard on to other people who maybe didn't get that message. In the classic game of telephone that can occur, especially in an emergency situation, that message can get lost. So what we really want to create is a foundational way to communicate the reliability of data in a way that is operationally focused, that is standardized, and that's really easy to communicate. So that's the background of the operational readiness levels, which, as you can see on this slide, occupies the top right quadrant of this pie chart here, which is a good overview of the different SICE data efforts that we have going on within the All Hazards Consortium. So I said my piece about data confidence and how the ORL model really fits into that, but there are other components of that effort as well. As you've probably heard many times at this, this exchange, the SICE is a way to share highly sensitive data. It's a way to create that confidence within organizations that their data that they might be sharing with a partner, with someone perhaps providing mutual assistance, that data is being shared in a secure environment. As many of you know, that's incredibly important. The operational aspect of things, we're really focused on creating solutions within the SICE and within the All Hazards Consortium to work with unstructured data. And oftentimes, during an emergency situation, the data that you might get might not have structure to it. It might not be GIS data. For example, it might be a PDF document or a text message or any number of things. I think all of us have seen lots of different examples. So one thing we really want to do is help create a process for streamlining unstructured data, for turning it into usable data that we can layer on top of other layers within a GIS to really leverage that data correctly. So that's really focused in on the unstructured information side. Lastly, the use case side has to do with really streamlining these problem-solving processes into certain use cases that people tend to run into over and over again. So obviously, if, we look at something like flooding, flooding is a good use case because pretty much every organization that manages physical assets out in the field is going to deal with flooding situations unless you live in the desert. And even then you might. So we really focus on looking at these different use cases like flooding or traffic and finding data and solutions that fit into those use cases. So it's a way for us to really organize all of our efforts and make them as effective as possible. So that is just a brief overview of the different data efforts that are going on within the SAIS. And then we can go to the next slide, please. So I just want to dig into this a little bit, and then I believe I'm passing it off to Karen to talk about some of the history behind the ORL model. So Karen, I don't know if it makes more sense for you to do that first, or for me to talk to the slide and then pass it off. What are the thoughts there?
Yeah, it might be good for Karen if you can talk a little bit about the history first, and then Carrie can dive into the flow chart. That would be great.
Perfect.
Yes, that works well for me. So thank you. Yeah, I'd like to really talk about the heritage of the ORL concept that we've developed and used and refined over the last 5 years or so. The SAIS ORL innovation really was conceived and developed jointly with the Earth Science Information Partners, ESIP. Little background on ESIP: it was created in 1998, and today it's supported by NASA, NOAA, and the USGS. It has over 160 member organizations, and the plan there is to promote the stewardship and use of Earth science data and information responsive to societal needs. The motto is making data matter, and we've taken that goal to data-driven decision-making with operational readiness levels. The ORL, the ORL was inspired by NASA's technology readiness levels, or TRLs. The goal is to demonstrate and expand the use of new Earth science data observations from new satellites in space. And it's been in use for over 25 years at NASA. They used it to really communicate the progress of technology, the maturity of the technology that NASA was developing, from research to prototypes to operational systems that would be used in space operations. It had 9 levels, and it was used significantly to help derive a better understanding of the technology. And what we wanted to achieve with ORLs was a better understanding of the data and its readiness for use in certain applications. The ORL was really based on experience that NASA and others in the ESIP world had with analysis-ready data. For example, making the archived Landsat data processing more accessible and easier to handle by creating packages, pre-processed packages. So analysis-ready data. Application readiness levels made satellite remote sensing data more applicable to programs dealing directly with, say, air quality or wildfires. And of course, with operational levels, operational readiness levels developed jointly with SAIS, we tailored it to address 4 levels of trusted data products, really to aid in the rapid assessing of factors for decision-making. By assigning readiness levels, this proved useful in communicating to users, the decision makers, the confidence and trust in the data to help solve these operational decision-making questions. So the ORLs are assigned based on data quality factors affecting, reflecting integrity, fitness for purpose. And this is evaluated in advance by the size processes that Carrie had led and a team of peers using the size use case approach. So this basically means that when you see the ORL assignment at any level 1 through 4, it's been assigned to a size supply data product on your system. You know that that data product has been evaluated by your peers to address your use case for that event. And that's basically the purpose of the ORLs. And since Carrie was involved in creating tools to help with the assignment of ORL levels and describing those 4 levels, I think this is a good point to turn it back to Carrie.
Great, thank you, Karen. That was a really good description of the history behind this. And I think it's important that we give a nod to the role that NASA and the technology readiness levels have played in creating this model. So before I dive into some of these graphics that you see on the screen, I really wanted to highlight that the GIS committee came together and worked through, what criteria we wanted to use when determining the ORL level of a data set. These are not, random, nor are they just pulled out of a hat. These are criteria that are really important. So as you can see on the bottom right, the ORL model decision tree illustrates how you get from point A to point B to rank a data set on the ORL model. So we ask questions like, does the data set come from a trusted embedded source? As Karen mentioned, if you're getting data through the SICE, you know that it's a trusted embedded source, especially if it's ranked on the ORL model. But in my example that I gave earlier, if you just find a data set online and you start to run with it, that may or may not come from a trusted embedded source. So if the answer to that question is no, or perhaps I don't know, actually what we recommend is that that data set not be ranked using the operational readiness levels model. The purpose of the model is not to say, oh, we don't want to use this data is not good, so we're going to give it a 4. The purpose of the model is to provide that situational awareness for the person making decisions on how reliable the data set is. But if we don't know where the data comes from, there's no way that we can possibly communicate that. So sometimes research has to be done to dig into where some data came from so that you can answer that first question. Some other criteria that we look at are security aspects of the data. How is it being served up? Is it SSL encrypted? Is it over HTTPS? Nowadays, most services are going to be SSL encrypted. Once in a while, you might come across a data set that's HTTP. It does happen. But if the answer is no to that question, that bumps it down to an ORL level 3. So as you can see, you kind of move down, we ask interoperability questions. Is it actually in a GIS format, shapefile, ArcGIS REST service, et cetera? Is it a service that has any downtime, whether that's scheduled or just over time, you see the service sometimes goes down. Change notification. This one is really important, and it's something that often gets overlooked. But if something changes about data, whether that's the way that it's being symbolized or the way that certain fields are being calculated, there really needs to be a process to notify the users that those changes are happening. If there is no notification, that can have pretty substantial downstream effects. And we find that that's often lacking with a lot of data sets. So we added that as an important part of that criteria. We also look at metadata. So metadata has to include certain components, things like spatial and temporal resolution, how frequently the data gets updated, the latency, the source, contact information. We have to know, who do we contact if there's something wrong, if the service is down, or if we have questions. Those kinds of things are put into that metadata completeness question. So if the metadata is not complete, that's also going to bump down the ORL ranking of the data. So on the left, you kind of get a sense for how we qualitatively refer to these ORL levels. Obviously, ORL 1 or 2 is available immediately. It's reliable. We know we can use it, and there's no questions about the reliability of that data. Versus a 3 or 4, you know, you might be looking at data that perhaps is in a testing phase, or it's not in production, or maybe it has scheduled downtime every weekend because there's nobody in the office. That does not mean that the data cannot be used, right? We just want that decision maker who's using that data to be aware of the fact that they might have to supplement the data with something else to make sure that their decision is the right one as they're using that data. So I think that's all I'm going to say on this slide, and I'm going to go ahead and pass it back over to Dave.
That sounds great, Carrie. Thanks so much. And I hope you're getting a good idea for the thought process that everyone was going through to create this flow chart. And Carrie put together this flow chart, which really helped bring it to fruition as we were talking about ORL 1 through ORL 4. And it's making a big difference, particularly within the ESIP Federation, as we talk to other science organizations and scientists and people who work with data. They say, wow, this really does make a great impression. The other thing is that these ORL definitions are still living. So we're taking these definitions and we're putting them back into the ESIP Federation. The ESIP Federation has a whole bunch of clusters. One of the clusters is data quality. Another one is disaster life cycle. Another one is agricultural and climate. Another one is drones. So we're putting this in front of some of those clusters and saying, hey, what are we missing from a data quality standpoint that may need to go into this as it evolves? And one thing that I'd like to do before we step over into a couple of examples, and I'm going to put up this title slide of examples, but I really would like some information from you that are watching in this panel discussion right now. We put together a couple of poll questions, and I'd like to pull up these poll questions. The first one, and this will help us understand how we communicate the data and the use and all that sort of stuff, just so we can understand the audience that's out there now. How would you best describe your position? So you can click that. And then there's a couple of other poll questions. There's another question down below that. How would you describe your role? And as you're clicking through those questions, there's going to be some other ones that pop up, including what is your skill level in data-driven decision-making? And think about this, you know, we're entering this era of, well, we've had a lot of data out there. It's growing exponentially, logarithmically, and we just can't process it all. One person just can't look at it and find all these data sets and process it all. So what's your skill level in data-driven decision-making? And then
Dave, let me go ahead and close this first poll and get the results to you. So
Sure. Okay, that sounds great. So here we go. Managerial policy, executive, and other. Terrific. How would you describe your role? As a consultant? Okay, so everybody that answered is consultant. Okay, terrific. So let's bring up the next set of questions, which is, what is your skill level in data-driven decision-making?
this is the only other one that I have.
Great. Okay, no problem. Okay. What is your, would you consider yourself a beginner, intermediate, or expert? And we'll just give you just a few minutes, another minute to answer that.
Okay, I'll close it in just a few seconds.
Sure.
All right, Dave, let's see what we have.
Okay. Excellent. Okay. Intermediate to expert. That's great. Well, thanks. That gives us a good idea for who we're talking with and your expertise level. So I'd like to show you some examples now of how ORLs are put together and what do we mean for like real-time products and things like that. I'm going to start at the top, ORL1. An ORL1 could be a data set, for example, that helps us do some detection. If you see an ORL1 next to a data set, it means that it's pretty highly trusted, it's operational, and it's something that is consistent. So an ORL1 data set could be satellite detected fires. For example, the NOAA GOES satellites look at the Western Hemisphere constantly from a geostationary orbit. And there are also lower Earth orbit satellites like NOAA 20 and the SUMI NPP satellite from NOAA that orbit from pole to pole and monitor things like wildfires. That data can be used, let's say, in data sparse areas. For example, on the right-hand side, could be used to deploy smoke jumpers in areas where there's not much population. This particular example is in Alaska, where there was a fire detected, and it was close enough to some villages that they deployed smoke jumpers to go in there and build a perimeter around that fire and stop it. ORL1 you can think of as a very trusted data set that's used for decision making. Another example would be the National Weather Service's radar data that shows real-time location of rain and snow and storms and other data that the National Weather Service sends out. Typically, a lot of their data sets are ORL1 because we trust them. They are an operational organization. An ORL2 is just as trusted. It just might not be as timely as you would like it to be. So, for example, a long-term drought outlook from NOAA's National Climate Prediction Center could come out periodically, let's say every few days. And that can be used to drive input into water management type decisions. We've had a lot of rain in the last week. It doesn't look like we're going to have any rain over the next 3 weeks. So that's going to help you manage your hydroelectric storage capacity for power generation. It's going to help you manage agricultural irrigation type of decisions. So it's still highly trusted. And I would say all these data sets are trusted. You might want to think about the timeliness of that data and how it appeals to your decision-making timeline that you have. An ORL3 could be, let's say, some research type sensors. This example is some research sensors that were around this volcano off the coast of New Zealand, White Island, I think it was called. And then it detected some rumbling in the island. Well, that island is also a tourist destination where people take tour boats over to that island so they can walk around what was thought to be not a very active volcano. And so here's the issue is that they're research sensors. This volcano erupted and there were 20 people on that island and many of them were killed because of the explosive eruption. That data at that time never made it to decision makers. Well, in an ORL framework, we would have access to these sensor data. We would operationalize them as ORL3, that some of them will work, some of them won't work. But if even one of those sensors worked and said there was activity, it could have led to the cancellation of those tour boats and lives saved. So that would be an example of an ORL3 data set, something that might not be operational, but it could be useful for operational decisions if that data was made available. ORL4, the bottom, would be something that could be emerging from the research world. Perhaps it's from a NASA satellite. NASA, remember, is not an operational agency, but they do fly sensors on satellites that are precursors to operational satellites that are run at NOAA or run at USGS, such as the Landsat satellite. This particular example is emerging satellite flood maps. I'm working with a group at NOAA that's looking at satellite data and how we can identify areas of flooding along rivers due to ice jams or due to river breakup, or just heavy rain. And so we can now take satellite data and create daily flood maps. And these are really good first looks at flood map indicators for where flooding might be happening. And so that could be used to redirect utility crews that are responding into flooded areas. Think about Hurricane Harvey, that massive amount of rain, over 50 inches of rain that fell in the Houston metro area. There was a large area of flooded roadways and urban and rural areas. So these satellite flood maps played a big role in helping FEMA understand just how extensive the flood inundation was around the Houston area. So this would probably be labeled as an ORL 4 currently, but it's on its way up the chain to an ORL 3 and even an ORL 2, where these flood maps are now being produced daily. And we're going through the process of just validating them to make them useful in even higher ORL levels. So that's an example of how different ORL level data can apply to situational awareness and decision making. So you see those ORL logos on the left-hand side, 1 through 4. Well, in the operational dashboard for the SEIS, we have the GeoCollaborate dashboard that's public facing. And as you can see in this dashboard, I've circled the area in the dashboard that has those ORL logos next to them. So in the dashboard, you as an individual user can click on and off these data sets, but you can also see what ORL level the data is. And you can click the ORL logo itself to bring up that ORL decision tree. So you can see, okay, well, what was an ORL 2? I don't remember what that was. You can click on the ORL symbol and the decision tree shows up and you can say, now this is what it is. And we could also, through metadata, lead you to other paths for maybe a webinar on ORL levels. The SEIS has some of those in its video library to offer as well. So this is just an example of seeing a dashboard. You may not be a data expert, but you want to look at those ORL symbols and you can see it's a 1 or a 2. Hey, I'm going to trust that. I know the SEIS and the ESIP Federation, they've all come up with this. I'm trusting it because I'm familiar with their processes and procedures, and move on with your decision making. So what we're trying to do is to create a dashboard here that allows you to do 30-second situational awareness and 30-second decision making. And so we'll be learning and getting feedback from you, I hope, over the next several months and during the year on what else can we do to make this data more trustworthy to you by adding to the definition of these ORL levels. And so the next slide is an example here of how we've used the dashboard in different situations. So you can see here, this is an example of a hurricane approaching the Gulf of Mexico. There was also another storm making landfall in the Gulf of Mexico. This is back in August of 2021. And so we have a number of data sets on the left-hand side of this dashboard that shows which ones are on, the ones with the little click boxes that are clicked, and the ones that are off, but they still have ORL levels associated with them. Sometimes data sets will show up without an ORL designation, and that just means that we're going through a testing process in the dashboard and within the SEIS before we operationalize the data set and give it that ORL level. And there's a whole question and answer survey that you can go through if you have data sets that you say, hey, I want to know what ORL levels these might be. You can put that your data and answer those questions, and it'll come out and pop out a number, whether it's an ORL 1 through 4. And then we'll go through and validate and verify that for its decisions. So I think, the ORL categories and rankings are very important because it drives other applications as well. So these ORL levels and data are being put into also the fleet movement app. This is the app through the SICE, the Sensitive Information Sharing Environment, that can help the movement of fleet utility vehicles down highways and pull up other sensitive information that's available within the SICE. So this is a non-public version. Only members can get access to it. It has 2.5 million data points that go into this dashboard and into this app. But what it really does is it merges weather, transportation, power outages. It also takes in routes, threats, and resources along those routes, so you can pull those out. And even if utilities were sharing the location of their vehicles, then those locations would show up on the map as well within their apps. So if you're looking for hotels or you're looking for open closed areas, that would show up. So it's a unique capability. It's not shared information outside of the SICE, and it's real-time operations that EOCs and industry ops centers can take in and look at as well. So this really helps. You know, one example is you have a fleet of utility vehicles going down, let's say I-95, and they want to stop somewhere, but they want to stop where the least amount of COVID counts are, and they want to stop where there's a certain number of restaurants open. So that's the kind of information that they can pull out from this particular application. And so the last slide that I have before we start a conversation here, and I hope you have questions and you're putting them in the chat, and we can talk about it, is this dashboard that brings in disparate trusted data sets from different locations. So this is an example of operationalizing in a damage assessment world data sets that are coming in from Dominion Energy that are doing their preliminary assessments and final assessments of damage, and also the Virginia Division of Emergency Management. So VDEM is also doing damage assessments, and that data is coming into the SICE. And in this dashboard, it's reflecting the combined organization's damage assessments, which could go a long way across other utilities, responding utilities, the mutual aid sectors, and others. So as this information comes into the SICE, it can be accessed. And this would be considered an ORL 1 type of data quality, because we're pulling data directly from the EOC at VDEM and also directly from a utility. And so they're doing their operational damage assessments. And you can see the big numbers. Dominion, reports 112 current IDAs. VDEM cross-track damage 41, and also requests for assistance 4,000 requests for assistance. This is all important for the SICE membership to understand what's going on here, and for folks like Greg at CISA to see what the needs are, so they can mobilize and they can do things to be very responsive and supportive of the private sector as they look to restore power. So I'm going to open it up to the discussion to Carrie and Karen and also Greg, and ask any one of the panelists if they would like to add anything else to what I've said, so we can start with this conversation. I'm going to start with Greg. Do you have anything else you'd like to add? To
yeah, Dave, this is great conversations. Look, and just the information's just so helpful and understanding. One of the areas where we can benefit as the federal government is, we have efforts going on right now to identify all of our data inventory systems, things of that nature, the metadata associated, the data dictionaries that go along with it. But what's real key is understanding the data from a federal perspective. And where this is really helpful on the ORL side is the ranking of the data. We're really, as the federal government, not in the business of ranking data. So here's an area where really the private sector, by doing this, can complement and give us better information and data to give us an understanding of how good that data is. Because, we have our own trusted and authoritative data sources, whether it's NOAA or DOE, Eagle Eye, those types of things. And there are some restrictions, whether you have to have a .gov, to get some of this information from DOE. NOAA data is pretty much open to everybody, but these are authoritative data sets that we use in understanding the weather data, the electric utility outages, and these are agreed upon numbers that we all are, in agreement. Nowadays, you look at, there's so many other outage data sources out there, whether at the state or local levels, that can get, it lead to confusion, in our reporting and agreed numbers. And we struggled with that for years until we actually came up and said, look, DOE is the number, this is what we're going with. But still understanding what other data sets are out there and how accurate those might be, in understanding the need, so we can better coordinate with the electric utilities, et cetera. So the ranking of data is extremely beneficial to us as we build our libraries, or as the AHC builds their libraries to this. So access to that information is very key for our operations, so that when our watch folks get in more information, we're constantly getting the tipping and queuing of information, whether it's open source or from our own sources, but validating and understanding what that data is, whether it's simple as reaching out to some of our regional operations or our protective security advisors or our cyber security advisors as we get reports in. So it's extremely beneficial what we're doing here on the ORL side. So, that's kudos to, everybody's been working on this, and look forward to more discussions on that. I think there's some really good, because I saw one really good question in here from Rosemary McDonnell, and it's the accuracy of data is critical. And I agree with that. But it's also how accurate the data is critical too. So if the data is ORL 1 or 4, we just need to understand why it is that, so that when you are using that data to support a recommendation, the source behind it and how good or accurate that data is. So
Yeah.
And then just to add to her question that she had, knowing where to deploy valuable resources. We struggle with that even internally on our watch operations, so that we can accurately deploy resources where it's needed, and where we are required to do that as CISA, whether it's on the physical side or the cyber side. So and then how do we ensure the national data is protected and readily available, especially during large events? First steps are things like this: knowing who you are and who to ask for this data and information. Sometimes folks don't have a seat at the table, but establishing those relationships with the government, with the private sector, utility companies beforehand, before an event happens, whether it's attending training or exercises, things of that nature, are extremely valuable when you come to the table and say, hey, I need this data set, and you're kind of in an event. And then if you don't know those people, they're less likely to share that with you. So whether it's establishing a relationship with the regions, with the folks that you work with, whether it's FEMA or CISA, our regional operations, those folks have all those PSAs, the cyber security advisors, and our chemical inspectors. And, you're more likely to get information. Obviously, there are restrictions with certain data, whether it's protected critical infrastructure information, PCII, PII type data, our CFATS data, which is all our CDI chemical data. That has certain handling instructions and protections that go with that. So, again, having those relationships and knowing the process to get that information or even request it, where we are really, we're, I won't say clamping down, but as we get more into the data governance and maturity of these programs, we're establishing unique ID numbers for a lot of the data and metadata. so we can better track that, understanding the data, what restrictions we have on that data. If there's licensing, if it's data that we bought from somewhere, we can't just forward that data, unless there's a specific agreement associated with that. So all that kind of goes into play with what we're trying to do on the data front. And it's going to be really, really interesting. It's as fascinating as we learn more and how we do this. How do we share information in a protected environment? Right now our situational awareness tools connect to GeoCollaborate. So right now we get a lot of feeds, geospatial feeds from AHC into our watch operations. But we don't really feed a whole lot out because of some of the challenges sharing a geospatial type, visualization to who may be on the other side. So there's, I won't say security issues, but I'll say there's a level of comfort in establishing those protocols to do that and do it in a secure environment. So more to come on that, Dave.
Yeah, no, that sounds great, Greg. That was really a lot, and thanks for addressing Rosemary's questions. And I'd like to ask Karen, if you have any other thoughts related to the ORL levels, how they might be evolving, how we continue to work with them in the ESIP disaster lifecycle cluster to get feedback from clusters.
Yes, I think that I've been picking up on some of the other sessions today and yesterday, the focus on communicating to various users of this data. And so within ESIP, we have been really addressing the issue of different parties with their terminology. They may be talking about the same thing, but using unique terms to their groups, and trying to solve the bridge that gap so that people understand at a common level. And often, coming up with some standard ways of handling the data and describing it is one goal, but it has to be kind of tailored to the use, which is what's so significant about the size, is that it's use case driven. And Tom Moran brings together people who are dealing with a problem that they all want to solve, and solving that problem together. Then you get at the issue of solving that communication issue. So I think that's an area where we'll see some more evolution here.
Yeah, and it's really interesting too, because we, now that we have this collaborative environment where anybody could connect, we could do exercises or things like that with the real-time collaborative capability of GeoCollaborate. It could bring people introducing new types of data that others could give feedback on, saying, hey, that could be really useful. So there's all sorts of ways now that we can interact with geospatial information, not just providing it as a trusted source from the SICE, but just saying, hey, on the outside, we're going to have some tests, or we want to have a little exercise or things like that. And then we could get feedback on how that data is being used, how it's expected to be used, and maybe the user isn't using it correctly. So it opens up a whole new way of interacting with data. Carrie, I wanted to ask you if you had anything else, and while you're making your comments, I'll take a look in the chat and see what other kind of questions have popped up.
Yeah, so I had a couple of thoughts. I think there are a few nuances to the operational readiness levels model that are worth highlighting. And these are both advantages or benefits of the model that I think none of us really envisioned from the beginning. One of those is, an often overlooked aspect of situational awareness really is having that questioning attitude. I think so often, again, and I keep reiterating this, but especially in a disaster response situation, things can be overlooked that end up being very important. And what something like the operational readiness levels model does is it can throw that red flag or that yellow flag that says, hold up, something's going on. I need to pause and take a look at this, right? So for data, that might just be something being ranked at an ORL level of 4. That may be all it takes to just cause someone to go, hold on, maybe we should verify this. Maybe we should, supplement this data with something else. That's so important, especially when it comes to issues of safety, for example. Just in my experience at Duke Energy, so often injuries in the field or major issues would happen because somebody didn't stop and ask a question, or they didn't pause when they were making a decision. So much of the benefit of something like this comes in those moments when it's absolutely critical to have a questioning attitude. The other aspect of the ORL model that is similar, I think, for a GIS professional, something common can happen, like I mentioned earlier, when you're finding data, you're on a time crunch in a situation. You might not stop and pause and look at the data and make sure that it's accurate, make sure that it's reliable. You might pass that data off to someone, and that person might use the data to make a decision. And, God forbid, if the data is wrong or it's outdated, somebody could get hurt, or, assets could be damaged or something like that. So as a GIS professional, it also creates an opportunity to pause, stop, and think about the data that you're adding to that dashboard or that you're sending along to that decision maker. I had direct experience with that myself. As at Duke Energy, we had started using the operational readiness levels. Several times there were moments where we had to go, hold on, let's see where this data is coming from. Let's make sure that we're sending along good data, because sometimes bad data can be worse than no data, as we've discovered. So that's all that I'll say. I'll turn it back over to Dave, but I just wanted to highlight a couple of points about that.
So Carrie, there's a new term in the industry that they're starting to use. It's called sense making. Exactly what you talked about. And it's a term I heard. I'm like, well, yeah, we're already using that, so, but if you hear sense making, that's where it came from, Sandia Labs. And, we're working some cyber issues with them, and they threw that term out, and I was like, all right, let's run with it. Yeah, it totally makes sense to me.
Sense making makes sense.
That really does. And Karen and I have come across that as ourselves in working on ESIP Federation meetings, kind of making sense of what you're hearing and how does that apply. I did want to get to Rosemarie's other question here. She says the data seems more reactive. How are you using this data to mitigate future risk? Which is a great question. I just have come off the heels of 4 days of American Meteorological Society meetings where we focused on risk and utilizing data sets where you can put them in front of people and help them understand their risks and vulnerabilities. Karen and I in the ESIP disaster lifecycle cluster just finished last week the winter meeting of ESIP, where we had a session on how can we place data sets in front of residents, homeowners associations, communities, so they can utilize things like satellite data, vegetation analysis to understand the risks that they have around their homes for wildfire. What kind of capability exists out there that we can use science, use observations to help communities understand what their risk is. And then once that wildfire develops, how can they get out? Do they need to get out? What kind of time do they have? This could also be applied to utilities across the country in identifying risks for wildfires and how fast wildfires could spread, given not only the meteorology involved and the setup for high winds, but the vegetation and the amount of fuels that are available to be burned. So that's a wildfire example, but I want to see if anybody else has any other examples or things to say. We have 2 minutes left in the session, but I want to make the most of it and see if anybody has any other things related to risk that you'd like to say.
Well, I'll make a comment based on a discussion earlier about the communication transparency that had come up in a session earlier today with resilience questions. And that is that it's so important to kind of practice before things happen. And that whole issue of getting people prepared, there was quite a bit of discussion around that with the healthcare and cascading problems based on electrical outlets, different problems, creating major problems after that. And so I think that really getting people to practice what to do before it happens. And these tools that we're talking about can make that interesting. I think that's going to be a key part of it, to get the public involved so that they can really appreciate what's at risk and what they can do about it.
Yeah, that sounds great, Karen. Thanks so much. I think what I'm going to do is wrap it up here. We really appreciate all of the attendees for this panel discussion on data quality and confidence. This session has been recorded, as all of them have been, and they'll be made available to everyone who's registered. So I'd like to thank Greg, Karen, Carrie, also George Giangi for introducing this session. And I'd like to throw it over to Laura for any closing remarks.
Dave, thank you. And thank you to all of our speakers today. And I'd also like to thank George for moderating this track for us today. George, I appreciate your time and effort in helping us